Hi everyone, welcome back. Today we are solving count mentions per user. So this problem is quite long, but I'll explain it as short as I can. So basically, the first input we have is the number of users. It will be an integer. And the second input we have will be an events array. And there will be 3 items in each item and events. There will be 2 types of events. And we will look at the first element to know. The first type is message and the second type is offline. And the second element of each event will always be a timestamp, and the third element will be the mention string or the ID. So if it's a message event, what we will do is at each timestamp, we will add all the IDs in the mention string. If the mention string mentions specific ID, then we add those ID. If the mention string says all, then we mention all users. If the mention string says here, then we mention all the users that are online. And if it's an offline event, then it will tell us that the user is offline at this timestamp, and it will automatically return after 60 time units. And we want to return an array mentions where it represents the number of mentions with each user ID after all the message events have occurred. So if we look at this example, first we will mention ID 1 and 0. That's why ID 0 is incremented by 1 and ID 1 also. Now at timestamp 11, ID 0 has gone offline, but it will come back in 60 seconds. So in 71, it will be back. Now at timestamp 71, it asks us who are the users online. Both 1 and 0 are back online. So that's why they get incremented to 2 and we return the output to 2. Now if we look at this example, ID 1 and 0 first get mentioned once here. Even though ID 0 went offline, the message at timestamp tells us to mention all, and all means we mention all users regardless if they are online or offline. So that's why they both become 2. So we return an output of 2 and 2. Now if we look at the last example, ID 0 went offline at timestamp 10. So when we get the message here at timestamp 12, we only mention ID 1. So that's why we return 0 and 1. So now that we have seen some examples, let's get to how we can solve this problem. So this problem is pretty straightforward after you understand what it's asking and after we have sorted this array, but we need to sort this array according to timestamp as its priority, and then we also need to sort by event afterwards for edge cases like this, because if offline and message happen on the same timestamp, we need to make sure we turn the ID offline first. But when we code the problem, actually we will sort by event first, and then after clearing the event, then we can sort everything by timestamp. But obviously, the priority is timestamp first and then the event second. After sorting the event, then we can use a count ID to keep track of the IDs that are mentioned. And then we will have a return time array to mention the time that the certain ID will return from being offline. And what we will do is we will iterate through each event. And if it's specific ID, then we will add the certain IDs. If it says here, then we will add all that's online to count. If it says all, we'll increment everything by 1 and count. And if it's offline, then we will update the return time of certain users. So let's go through this example real quick. So first we see message at timestamp 10. We need to update ID 1, ID 0. So increment both by 1. Now we come off timestamp 11. We see that ID 0 wants to go offline. So we update the return time to 71. And now we come to the last message or event. And we see that at 71, we want to mention all users are online. And by the time it's 71, user 0 has returned. And user 2 is obviously already online. So we increment both by 1. And now we have come to the end. We can return this as our result. So the time complexity would be O of nm plus nlogn, where n is the number of events and m is the number of users. So it's nlogn because it may take that time to sort the event, and nn because after sorting, we will iterate through each event, and within each event, we may get messages like all or here, where we will have to iterate through count and update every single ID. So that's why it's n times m. And the space complexity would be O of n plus m, at least for Python. So the m will come from the number of users for arrays such as return time and count, and the n would just be my Python sorting method, so it will take n space, but it depends on what sorting method you use. But I know for Python the built-in sort method uses n space, so that's why it's n plus m. So now let's get to the coding part. So first we will sort the event, and we want to sort first by the message or offline, so it would be reverse to true since O comes after then M. and then we will sort by the timestamp after we take care of between message or offline. So it would be the end of E1. Now we initialize count and return time, so it would be element 0 times the number of users, and the same for return time. Now we can look through the event. So for event and events, and we will keep a time variable for event 1. Now if the event is a message, then we need first check if the message is all. If it is all, then we will just look through the number of users and increment everything and count by 1. So count of I plus 1. Then we will check if the event message is here. If it says here, then we will look through the return time array, and we need to make sure that for IT in return time that t is less than or equal to time. If that is the case, then we increment count of I by 1. Otherwise, then we will look at the message directly. So for index in event 2 dot split and count of integer of index from index 2 to the end, because the first 2 letters will be ID, so 2 to the end plus 1. And otherwise, then we will just look at the return time of int of event 2, and it would be time plus 60, because if it's not message, then it's going to be offline. Then we can return count, see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.